Hello, my dear students. I hope you are all doing good. We have a new math lecture today. I will share the screen, and this is a new lecture, but we have seen also this lecture last year. We have worked a lot with this lecture last year. And as you can see, the title of our lecture 3 is about algebraic expressions, or it is called polynomials. This is part 1 of our lesson. So this is the first part of our lesson because I have divided this lesson into 2 parts. We will start now talking about the objectives of our lesson. As a reminder, I will remind you of monomials. What do we mean when we say like monomials or like terms? What are polynomials? What is meant by reducible polynomial? Objective number 2, we will perform operations on algebraic expressions or polynomials. 3, I will remind also you about how we expand or develop, reduce and order an algebraic expression. What are the rules that we use? Number 4, we will factorize an algebraic expression. Number 5, calculate the numerical value of an algebraic expression. And finally, I will remind you how we solve equations of different forms. As you can see, these objectives, we do not have any new objective. All the objectives we worked on a lot last year in our grade 8 class. So what do we mean when we say a monomial? A monomial is in mathematics a sign, positive or negative, a coefficient or a number, a variable with an exponent. So if I look at this example here, a x to the power n, this is a monomial in the variable x, where a is the sign or the coefficient of the monomial, x is the variable, and n is the exponent of the variable. When we talk about similar or like monomials, have same variable and same exponent or degree. For example, if I give you the monomial 3x cubed and minus 5x cubed, these two monomials are like or similar. Why? Because I don't care what is the coefficient of the monomials. I look at the variable here, it's x, and the variable here is x. The exponent of the variable or the degree of the variable is a 3 in the first one, and it is a 3 in the second one. So these two monomials are called similar monomials. While 2a squared and 2a cubed are different or unlike monomials. So here, if you look, the variable is a and the variable is a, but the exponent of the first variable is 2. The exponent of the second variable is a 3 because they have different degrees. So these are different or unlike terms or monomials. As a note, the sum of 2 or more monomials in X is a polynomial. So if I add 2 or more monomials together, I get a polynomial or an algebraic expression. I have here, for example, monomials. 5x cubed is a monomial, minus 3x squared is a monomial, and x is a monomial. If I add all these, I get a polynomial or an algebraic expression. My algebraic expression will be 5x cubed minus 3x squared plus x. This polynomial has a degree 3. What do we mean by the degree? It is the highest exponent of the variable. Here the exponent is 3, here the exponent is 2, here the exponent is 1, so this monomial has degree 3. What do we mean when we say a reducible polynomial? A polynomial is said to be reducible if it contains similar monomials. So if in a polynomial we have similar monomials, we can reduce these similar monomials together. We can add them or we can subtract them. But as a note also, we can only add or subtract like monomials. To add or subtract monomials, we add or subtract their coefficients, we keep their variable and exponent. If I have minus 6x cubed plus 2x cubed, these are two like monomials. So here the coefficient is minus 6 and here we have a plus 2. Minus 6 plus 2 is minus 4 and I keep the variable with the exponent x cubed. Here I have a polynomial p of x. This is a reducible polynomial. Why? Because the 3x squared minus 5x squared are like terms. So we can add or subtract these. 3 minus 5 is minus 2 and we keep x squared as it is. Now, if we look at plus 7x and minus x, plus 7 minus x means minus 1x. Any monomial with no coefficient, it will be 1. So plus 7 minus 1 is a plus 6 and we keep the variable x. Minus 5 plus 8 is plus 3. So this is how we add or subtract monomials and reduce a polynomial. Now, operations on polynomials. So if I have polynomials, which operations I can perform on these polynomials? Addition and subtraction of polynomials. If I have two polynomials, for example, the first polynomial is p of x, this is p of x. The second polynomial is q of x. If I asked you p of x plus q of x, so this polynomial, I want to add it to the second polynomial. If the sign here in front of the second polynomial is plus, this plus does not change the signs of the monomials in the second polynomial. So what do I write? P of x, I write it as it is, 4x cubed minus x squared plus 2x plus 7, plus I want to add q of x. So I write all the monomials of q of x as they are with their signs. Why? Because the plus here does not change the sign of the monomials in the second polynomial. Then I add or subtract like terms together to reduce. While a minus sign in front of the second polynomial changes all the signs. Here I have minus q of x. So I write minus 2x4. Negative times negative is positive x cubed. Positive times negative is negative x squared. Negative times negative is positive 5x. Negative times negative is positive 4. Then I reduce the like terms in this polynomial. Also, as a note, the answer of addition or subtraction of polynomials must be ordered. What do we mean by ordered? If you look here, I start writing the variable with the highest exponent first. So x4, x cubed, x squared, x1, and finally, I write the number without the variable. So our answer should be written in order or ordered. Product of polynomials. To multiply two polynomials, we replace each in between parentheses, then we start multiplying terms together. How do we multiply terms of our monomials? As we said before, we multiply sign times sign, number times number, variable times variable. If we have different variables, for example, x times y, it's xy. But if we are multiplying same variables, we keep the variable and we add exponents. Now I have This is the polynomial p of x, 2x squared minus x plus 3. Q of x is minus x squared plus 3x minus 5. So I want to calculate p of x times q of x. I replace the polynomial p of x in parentheses, and I replace q of x inside parentheses. Now we start multiplying. What is the procedure of multiplication? We start 2x squared times x squared, then 2x squared times plus 3x, then 2x squared times minus 5. Here we multiply all for all. This rule is used in multiplication. Then after I get the answer, I order and reduce my answer down here. So to expand or develop reduce and order a polynomial, we follow these 3 steps. We get rid of parentheses, we add or subtract similar monomials, we write the degree in increasing order. I want to remind you now with the rules of expanding an algebraic expression that we talked about a lot last year. First, we have the first rule, which is a parenthesis multiplied by something outside. It might be a sign, m might be a number, it might be a monomial. How do we multiply? We use the rule 1 for all. Here, if we are multiplying 2 parentheses together, we use the rule all for all. M times A is MA, plus or minus. M times B is MB, plus or minus. N times A is NA, plus or minus. N times B is NB. Or we can use one of the 3 remarkable identities. A plus B all of its square equal A square plus 2AB plus B square. A minus B all of its square, A squared minus 2AB plus B square. A minus B into A plus B is A square minus B square. These remarkable identities should be memorized. As an example, we should expand, develop, reduce, and order A of x. So A of x is given in this form. Here I have parentheses. Before this parenthesis, I have a minus and I have square on it. So first I should get rid of the square. So this is the second remarkable identity, A minus B all of it squared. It is A squared, which is 4 squared 16, minus A times B. 4 times 3x is 12x, times 2 is minus 24x, plus b squared, 3x all of it squared is 9x squared. Here we do not have parentheses, so we write them as they are. Here I have 2 parentheses multiplied together, also multiplied by minus 3. So I keep the minus 3 first. Here I apply all for all. After I got rid of all the parentheses, I reduce my answer and write it in order. How do we factorize a polynomial? To factorize means to find a common factor between the terms of the polynomial. Then we divide each term by the common factor after we open parentheses. Also, we have rules used in factorization. These rules are opposite to the rules of expanding. In expanding, we are getting rid of parentheses. So in our answer, we should not have parentheses, while here in our answer, we should have parentheses. Either we use the remarkable identities or we use the common factor rules. As an example, here we have to factorize f of x. Here I have 3 terms, so I have a squared minus 2ab plus b squared. I write it as a minus b all of it squared. This is factorized, so I write it as it is. Here I have 2 terms, a squared minus b squared. I write it as a plus b into a minus b. Between this term, and this term. So since we have 3 terms, we take a common factor to x minus 3, and we divide each term by the common factor. After that, I get a factorized form. Now, how we calculate the numerical value of a polynomial. So if we have a polynomial in X and I wanted to find the numerical value of this polynomial, we replace the given value of the variable in the polynomial, then we calculate. Given this polynomial a of X, we should calculate a of -1. So X in this polynomial will be replaced by -1. So I replace it and I calculate my answer. As a note, always to find the numerical value of a polynomial, the polynomial should be written in expanded form. As you can see, this is expanded form without parentheses. So directly I replace and find the answer of the numerical value of the polynomial. Now, also as a reminder, how do we solve equations? We know what's an equation. An equation is a sentence in math having two sides. Between the sides, we have an equal. So if we are given any equation in X, to solve it is to find a value of the variable X. So if we are solving an equation on algebraic expression, we might be asked, we should solve P of X equals 0, P of X equal Q of X, or P of X equal K, where K is a number positive or negative. If we are given the first two forms, P of X and the Q of X should be written in factorized form in order to solve correctly. While if we are given P of X equal to a number, then P of X, I should take its expanded form in order to solve here. After solving an equation, a solution or a root might be one of these four forms. If I have A of X equal B, then the solution X equal B over A. This is the simple equation form. A of X equals 0, then X is equal to 0. 0x equal a number. This has no solution. 0x equal to 0. Here, X has many solutions. Please pay attention to these forms of equation. They are very important. And as an example, I have given you here a polynomial P of X. You should expand, you should factorize, you should find the numerical value, and you should solve. This is given as a practice on all the ideas I have discussed or reminded you about in this lecture. Please try to solve this exercise on the slide here. It is solved for you. Try to solve it on a draft to practice more. And as I always say, if you were studying and watching this video, after you watch it, if you have any question, please contact me and I will be ready to answer all your questions. Thank you.